Okay, in this video we are going to look at how to create a stiff cloth. Again, we are starting with one of the cloths from the cloth example. So let's first hide the MyGeos because that's just going to slow down our sim otherwise. In order to get a stiff cloth, we're going to have to A, increase the stretch and bend stiffness, and B, increase the number of iterations because a stiff cloth needs more compute than a soft one. Let's first do a baseline sim so we can see where we're starting from. Okay, let's up the stiffness. Let's try 1000 for stretch and 1000 for bend, and let's see what that does. That's a bit stiffer, but not really having that much effect. Okay, let's try 10,000. Still not having much of an effect, and I suspect that's because we need to run more iterations. So let's go over to the simulation settings. So the number of iterations we are running per frame is basically the value in the iterations box multiplied by the value in the subdivisions box. So here we have a total of 200 iterations per frame, and we probably want to up that 5-fold. Now we can do that either by increasing the number of iterations or the number of subdivisions, because in the end we're just multiplying them together. But increasing the number of subdivisions gives us more effect for the compute cost, and so let's increase that from 20 to 100. Okay, let's run that sim again. That's starting to look a bit more like it. Still not as stiff as I'm looking for, but it's getting there. I'm really aiming for something that behaves like a steel sheet to really show you how to crank it up all the way. Okay, let's go back to our cloth parameters and check out a few things. Our cloth is weighing 250 grams per square meter, and that's fine for a cloth, though it's a bit light for a steel sheet. But if we up the weight, we'll just need more compute, so let's just leave that for now. And looking down at the other parameters, because I'm going for something really stiff, I don't want any compression or extension, but depending on your situation, if you have your cloth constrained by other objects, you may want to leave in a little bit of compression or extension so that the cloth can move around a little bit if needed. But here I'm going to remove it. And also in that last sim we did, you could see we were capturing some of the plastic behavior, and I don't really want that either. So let's zero out the plasticity. Okay, let's try running that. Now that's starting to look a bit more like it, but I want it even stiffer. I don't want it bending over the edges so dramatically. I want something flatter. So let's crank up the stiffness another order of magnitude to 100,000 and see what that does. Not a big change, and I suspect that's because we've got to go back and crank up the iterations yet again. So back to our simulation settings, and let's crank up the number of iterations to 25 and the number of subdivisions to 200. You should be aware that as you put in more subdivisions, it's increasing the frequency of the sim, and that can make the sim more lively as it's capturing higher frequency movement. Now let's see how that runs. It's starting to get a bit slower because we're really making it do some serious work. Okay, that's a lot flatter now, and we can keep tweaking these parameters to get the look we are after. So you can tweak the balance between subdivision and iterations to suit the final look you are going for, but we don't recommend going above 200 subdivisions for a 24 Hz sim. That's a 4800 Hz sampling rate. You can also bear in mind the type of geometry you're using. If you're creating something that's very stiff, there's no sense in using thousands of polygons to do that, because you're just creating a bigger network problem for the simulation to solve. So if you're finding that you're having trouble getting something stiff, even with a lot of iterations and subdivisions, take a look at just how much resolution you're working with, and maybe you could work with 1/10 of that resolution, and that would make the sim run much, much faster. Thank you for watching, and happy simming.